Hey there, hope you're having a good day. Today we are talking about the blueprint interface and the JRPG Combat System, okay? The JRPG Combat System is a classic turn-based combat system. It includes a full suite of functionality that allows you to focus on other aspects of your game. It is designed to be easily integrated into existing projects while providing flexibility to pursue your creative goals. In this video series, I'm detailing the entire JRPG Combat System, allowing you to learn the system, modify it, and even build it yourself. You can buy the product online on the Unreal Marketplace. Links in the description. Obviously, you are free to follow these guides and build it yourself. No purchase necessary. Today, we are talking about, like I said, the blueprint interface that's used throughout the combat system to interact with combat actors. We're doing things like taking damage, healing HP, spending mana, using custom skills, alerting our status effects to trigger. All of that stuff that happens on the actor is defined through the functions that you use with this interface. So you can learn about blueprint interfaces by Googling Unreal Engine blueprint interface. You'll learn a lot if you're not familiar with them. But to sum it up, an interface is where you define the input and output of a function that presumably you're going to use in multiple places. So in this case, we have a fixed position, okay? And it has an input of new position, an output of OK. New position integer, output OK Boolean. And then if we go to fixed position here, you'll note the input and output I can't change because I define them on the interface, and I do stuff in between, and then I provide the output after receiving the input. You put this on your combat actor by going to class settings. Under implemented interfaces, you choose add. You select it here, and I've already added it, so it's right there. Okay. But yeah, you should, if you're not familiar with blueprint interfaces, you should go look up a guide or read about it a little bit. It's incredibly useful, and it's important that you understand how they work. So what I'm going to do here is I'm going to talk about each of the functions on the interface and their purpose. I'm going to show how I've implemented in the example, which, I mean, you can use the example if you want, but usually you would customize it to suit the needs of your game, right? So I'm going to focus on the purpose of these functions. I'm going to go quick because there are quite a few. And hopefully this gives you an idea of how you would use it, okay? So the change attribute, let's start here, change attribute. The purpose of this function is to adjust the attributes on the actor, okay? Input attribute to change, flat change plus or minus is an integer, percent change plus or minus is a float. And so you can change attributes flat or by a percentage. And it uses this function, this helper function is what I call it in the function library, to use pass by references to change the corresponding attribute, do the math, change it, and then it outputs an amount changed in case you wanted to use that for some other functionality to do something based on the amount that was changed. Okay. Healing. So the healing, draining, all of these, heal MP, drain MP, heal HP, take damage, which is like drain HP. These are all pretty similar in their purpose. So heal MP would be like you use an ability, you're spending MP, and then you want to restore that MP later so that you could use more abilities. Pretty common functionality in a JRPG. And what this does is it takes a flat amount or a percent amount as a float, and it will drain it or heal it by that amount, restore MP by that amount, okay? So in this implementation of it, and then the return value is the actual amount that was restored. In this implementation, the first thing I do is check if the character's dead and that both of those are greater, either of those, not both, either. So you can use flat and percent. That functionality is supported in this implementation of it. But either of those need to be greater than 0, and the combat actor has to be alive. And then we do some math. We have a helper function, heal with max limit, which basically restores, but then caps it at whatever the max is. Spawn some floating text to represent, because you expect when you like heal something or deal damage that some text with the amount dealt or healed will pop up. So that's that. And then we set the current MP based on what was calculated before and return the amount healed. Okay. So that's heal MP. Like I said, these next three are going to be very similar. Drain MP, we're doing pretty much the same thing, except obviously we're subtracting HP. So there is a lower limit of 0. And so if it's less than 0, less than or equal to 0, it's going to set their current MP to 0. That's probably the only difference here. And I'll try to get all of it in there. So in case you were copying this down, you want to use this implementation, you can. Obviously, this is included with the example in the JRPG Combat System. And then here we are spawning the floating text. Heal HP. Ooh, this looks really similar. I think we've seen this before. Heal with max limit. So same as heal MP, right? We're setting the current HP. We're returning the amount healed. There's one addition here. A Niagara system spawns that has a sound effect associated with healing. This is an example of how you might implement different effects into the game that trigger on healing or taking damage or this or that. Here's floating text and returning amount healed. Take damage. You'll notice a lot of the same. Here, though, because often when you take damage in a video game, you have a defense stat that can reduce damage. And so what this does is it actually calls this interface, give attributes, which we'll go over here later, it's down here, and gets the response on the defense integer of that. And you might wonder, why would I call this instead of just grabbing the defense variable why wouldn't I just grab this variable that I already have here? Well, part of the reason is it's kind of discipline, because you want to have one source of truth for that kind of information. And let's say you change the this interface to have some kind of modified response and defense. You would want that reflected everywhere that you're using that attribute. Okay, so it is a matter of keeping things really structured and disciplined is why I did that here. But you take that defense, this calculation basically makes 50 defense be 50% damage reduction. Okay, and that's what this 50 represents. So if I put 100 here in this little part of the equation, 100 defense would be 50% damage reduction. That's a pretty common way to calculate defense, but you can put your own method of calculating defense here. This is where you would do it, right? We're making sure we're alive before we take any damage and that the damage that we're going to take is greater than 0. We're spawning a Niagara system. We're spawning some floating text. We're setting our current HP. Based on the HP set, we're setting the isAlive variable. And then, if we are still alive, we're playing a hit animation using an animation montage on our character. If we are dead, we're playing I got these backwards. This one's take hit, this one's die. But in any case, so we're dead, we play a die montage. We're still alive, we just play a little hit montage, right? And we return the amount taken. So that's the big difference here, is the death management part of of the system. Okay, so that's take damage. Take effect. This is applying an effect to the actor, which is the effect is an actor component that basically ticks for a duration of turns and does different things either at the start of the turn or the end of the turn. Things like modifying attributes, dealing damage, healing HP, that sort of stuff. Basically, what you would expect out of like a poison effect or maybe a defense buff on a character. You know, that's what an effect is. And what this take effect does is it's basically telling the actor to create that actor component and give it to yourself. Okay, so create an actor component on yourself, which is later called by the combat engine as turns progress. Okay, so this take effect, it's effect data or it's an effect class. And in this implementation, I actually have a bug in this implementation, and I'm going to show you that. Okay, so it's an this or this. So either we do an on-the-fly effect data, or we can use an effect class. An effect class would be like a predefined blueprint actor component class that we created beforehand. We've defined everything in it. And so if we're choosing an effect class here, we presumably haven't put any effect data. And here's where the bug is. So the first thing we do is check if we're alive. That's, you know, we want to do that, obviously. But then we also check to make sure the duration of turns on this effect data is greater than 0. That is a bug because if we selected an effect class, presumably this is 0, so it's always going to go to false, which is going to go straight to the end. Okay. So I'd change that by making this just check if we're alive, because we're checking is valid class here. And then if it's not a valid class, we would then do this check here before we add this effect. Because if the duration of turns is 0 or less, then obviously there's an issue with what we implemented. And we don't want to add that to the actor. So anyway, so what it does is it checks if the valid class, if this input is a valid class, because if we selected something here, that's what we want to add. And here we, if it is a valid class, we're just adding that actor component based on the class, setting the applying actor from the input here. And then if that wasn't a valid class, presumably we're taking that effect data and applying it directly to just a baseline BP effect class. We're setting some tags on it based on the tags here. If it is beneficial, we go straight through. If it's not a beneficial effect, we have a little Niagara system that plays on the character for a negative effect. Okay. So that is take effect. Again, purpose is just to apply an effect to an actor. Spend MP. This should be pretty straightforward. You use a skill, you want to spend MP. One thing to note about this is there's a way to check cost without spending, and then returns if the check passed or not, and the true cost. And this is used twice when a skill is used. Once when you're selecting targets, because you can't select targets if you don't have MP to spend. And then again when the skill is actually used, it spends the MP. Okay. And you'll notice pass by references on current and max MP so that we can set the current MP accordingly if we're spending it. And so in the actual helper function, the first thing we're doing is we're getting the total cost, and then we're going to get our remaining MP if we were to spend it. And if our remaining MP is greater than or equal to 0, it passes. Then, if we're only checking it's going to just return. Or if we did not pass, it's just going to return. Okay. But then otherwise, we are actually spending, which sets the by ref on the current MP, sets it to that remaining MP local variable that we set earlier. Okay. And I'll just pause here in case you're copying that down. This is a helper function in the blueprint function library. Okay, so that's that. Use custom skill. This is in the skill system. You can have custom skills that do things completely out of the bounds of the typical skill system that's provided. This is where this would trigger if you have it set to use the custom functionality, and this just feeds in the skill, the target, and then you would put your custom skill functions here, how you want to handle the skills, the custom skills. Okay. Okay. Alert effects intern. I mentioned earlier that effects trigger on start and intern. This helper function here cycles through all of the effects and tells them in turn, which they'll trigger their own things that happen on in turn. Okay. For each loop on all the BP effect components. The bookends are just diagnostics for troubleshooting purposes. Same things for start turn. Alert effect start turn. For each does a start turn. Bookends are diagnostics. Okay. Leave combat. This is where the purpose of this is to kind of wrap up things with all your actors. If you're using like dummy actors for combat, not your overworld actors, this is where you might destroy them. But yeah, that's just combat. Fixed position. The combat system manages the position of all the actors, like position 1, 2, 3, and 4, like a lineup order. And if two actors occupy the same position, the system needs to be able to tell them, no, you go here instead. And that's what this does, because the position integer is managed by the actor itself, even if the combat system needs to control it. And that's the purpose of this. So really simple, just set the new position. Join combat, just tell your actor, hey, you're joining combat. Pretty straightforward here. This is where you might, this isn't actually used, but this is where you might implement some kind of random encounter. So like the odds and then the level name to be spawned. This is not currently implemented, but that was the purpose of it there. Give skills. Use as a helper function to get all of the skills on the character, because the skill names is just a list of the names in the database. These aren't actually records. And so when requested, the actor will use this get skills to actually get the skills array from the data table. And to show you this, all it does, bookends are diagnostics. And then we're filling in the skill output array, which is what is eventually returned, by looking up each row name in that list from the skill data table. And then we return that. Okay. If it's not found, more diagnostics for troubleshooting purposes. Okay. Give attributes. If you were to implement this, this might be a good place to start in your implementation. You just right-click each of these, promote to variable, because this is the simplest implementation. It's just one-to-one. You could add some functionality here to kind of adjust things and make it work a little different. But this is the simplest implementation. Give name and status, same thing. Right click, promote to variable if you don't already have them. And then you're implemented and you can configure those things. Okay. So that's that. Okay. I went over all of these different functions and their purposes. If you have any questions, please put them in the comments below. I think that's all I wanted to cover. I hope you have a good day.